Welcome! Today we are diving into the fascinating world of maze generation and how it's connected to graph theory. Graphs are these things. They consist out of nodes and edges. Maze generation algorithms are essentially ways to create a spanning tree out of any graph, which is a subgraph connecting all the nodes without any loops. Now you might ask, how does this relate to mazes? That's a great question with a simple answer. We can convert graphs to a grid by assigning each node to a cell in the grid. We can then say that when there is an edge connecting two nodes, that there are no walls between these two cells. That way, any spanning tree can be converted to a maze, and that is exactly what we did here. Alright, that's enough about graph theory for now. Let's grab some pen and paper and start drawing our own mazes. Let's start with one of the simplest maze generation algorithms, the binary tree algorithm. We'll start at the bottom left corner of the grid. For each cell, we'll flip a coin to decide in which direction we want to carve a path. Heads means north and tails means east. Let's flip the coin for the first cell. We got heads, which means that we will now carve the path to the north of the cell. Now let's go to the cell to the right and repeat this step. We got tails on this one, which means that we will carve the path to the east. Now let's repeat this step for the third cell of this row. We got tails again, which means east. And now we are on the easternmost column, which means that we have to remove the northern wall. In fact, we have to remove the northern wall for all the cells that are in the easternmost column. And the same goes for the northernmost row. The reason for this is that the algorithm has no choice except for going in that direction. I will now repeat steps 1 to 3 for the remaining cells and then come back to you. Alright, this is the maze that the binary tree algorithm came up with. You might directly notice that there are passages on the north and the east. This is what it's called a bias, and every algorithm has it to some degree. Of course, this is a very simple grid, only 4x4. And we will now go into Unity and I'll show you what is possible with the tool I created for the binary tree. We are now inside the Unity editor, and in my scene I have a game object with the grid displayer component attached to it. This component has many settings. For example, you can change the size of the grid and the size of each cell. And for the binary tree specifically, we have an option to set the bias. In the previous example, I showed you the binary tree with a northeast bias. So what will happen if we change it to southwest and generate a maze? As you can see, now the pathways are along the west and the south of the grid. And what this change does is that for each cell, when we flip a coin, we don't decide if we go north or east. Instead, we decide if we go either south or west. And in fact, you can do this for any configuration, and the pathways will adjust accordingly. Alright, that was it for the binary tree algorithm. I hope you enjoyed it, and I hope you could learn a thing or two. Next up, there is a video planned for the Sidewinder algorithm and also one for Kruska's algorithm. So stay tuned for that. Other than that, thanks for watching and see you soon.